Hello everyone, my name is Viraj and today we'll be looking at the 19th problem from the CP-31 sheet by TLE Eliminators under the 1000 rated questions. Let's go. So moved on to my sheet over here, ticked off 1000. Let's go to the 19th problem, Divan and a new project. Let's read this. The company Divan's Sofa is planning to build n+1 different buildings on a coordinate line so that the coordinate of each building is an integer number. No two buildings stand at the same point. Let xi be the coordinate of the ith building. To get from the building I to building j, Divan spends xi minus xj minutes mod, where mod of y is the absolute value of y. All buildings that Divan is going to build are numbered from 0 to n. The businessman himself will live in the building 0 and the new headquarters, that is Divan's Sofa. In the next 10 years after construction, Divan will visit the ith building ai number of times, each time spending 2 into x0 minus xi minutes for walking. Divan asks you to choose the coordinates for all n+1 buildings so that over the next 10 years, the businessman will spend as little time for walking as possible. Okay, so they've given you a very big problem. Let's condense this into a very simple statement. They begin by saying a story that there is some person and he's trying to cover a distance. We have to minimize that distance. That is like the rough idea. So we are saying that there will be n buildings that will be constructed on a number line. So I'll take a number line like this. I'll say this is my number line. On this number line, I will construct n buildings and each building will be visited ai number of times. So they'll be given an array of n size where these values will be a1, a2, a3, a4, so on till an. So if let's say I pick up this value and I say, what is this a4? This a4 denotes that building 4 is visited a4 number of times. Now, these buildings will be placed at some coordinates by me. So I'll choose some coordinates for them. On this number line, I'll first place somewhere wherever I want the headquarters. So let's say headquarters are over here. Let's say this is 0th building or headquarters. And then somewhere or the other, I'm going to place this first, second, third, so on till n buildings. So maybe I'll place the first building here, the second over here, the third over here, the fourth over here, maybe the fifth over here, and so on, let's say sixth over here, anything that I want. I do something like this. When I have placed these buildings, now I imagine that a person that was standing over here, that is the businessman, he is going to visit the building these many number of times. So let's say I pick up from this location, the building 3. I will visit this building a3 times. So if I say that what is the time taken to visit the a3 building, for one time you will consider the distance from, you can say like this, 0, went to 3, and then came back from 3. So this is one visit, went from my headquarters to the third building, came back. Now this is something that I'm going to do a3 number of times. So I'll say that the third building is going to overall take a time period of a3 into whatever is this sum that comes up. Let's say overall these two segments sum up to some value s. So a3 into s is actually the time taken to visit the third building from my headquarters a3 times. Great. Now I have to do this for all the buildings. I'll calculate this particular value for everyone. What is the A1 segment sum that comes up? What is the A2 segment sum that comes up? And so forth and so on. I do this for till an and I sum everything up. When I sum everything up, this of course turns out to be some value, let's say answer. And this is something I want to minimize, which means I have to smartly do some placement of these buildings as I showed you. I did some random placement. You would want to do some smart placement over here so that this value is the least one possible. Okay, this is actually the question. Let us quickly see a test case and understand what is the placement over here. Let's say I'll take up this second case, 3, 8, 10, 6, 1 and 5. So this means there are 5 buildings I want to construct, 3, 8, 10 and then 6 and 1 means I'm going to visit the first building 3 times, second building 8 times, third building 10 times, fourth building 6 times and fifth building 5 times. Now what is the answer? The answer is over here 78, that is the total time taken, and then are also asking what arrangement do you follow to do that. So this is 1, -1, 0, 2, 3, 4. So 1, -1, 0, 2, 3 and 4. This means this is the 0th building, first building, second building, third building, fourth building, fifth building. Let's actually draw this on the number line. If let's say this is the number line that you have, so I'm saying that I'm keeping the 0th building on the coordinate 1. So this is coordinate 1. this is 2, this is 3, this is 4, this is 5. On the back, this is like 0, then this is -1, -2, -3. This extends over here to, you can say, -infinity. Since this is a number line, this is positive infinity. So where do you place the 0th building? You place this at the first location. So let's say this is the 0th building over here. Or you can say B0, building 0. Then building 1 is at -1, building 2 is at 0th coordinate, building 3 is at 2nd coordinate, building 4 it is at 3rd coordinate, building 5 is at 4th coordinate. Okay. Now let's get the total value. If I say that what is the time taken overall in the span of whatever they said in the storyline, 10 years or whatever you call that, you basically are picking up, let's say, the first building and you're visiting it 3 times. So from 0, that is the headquarters, if I talk about the first building, the distance is going 2. So 1 to -1, this is 2 distance. Then coming back, this is again 2 distance. So one trip takes 4 seconds, 2 plus 2, 4 seconds. And then you're doing this 3 times. So that means you do 4 into 3. And this turns out to be 12. So this means that from headquarters to building 1 in the next years, you have taken total 12 units of time to do a trip to that building. Let's do this for B2, B3, B4, and B5. So for B2, this turns out like it's at the 0th coordinate. You want to visit it 8 times. The difference right now is between this 1. So 1 plus 1, round trip. 2 into how many times? 8 times. This becomes 16. Okay, let's do this for B3. Now for B3, this would be a distance from here to here. So this is going to be a distance of 1 again. So I'll say round trip takes 2. 2 into how many times? 10 times. So this becomes 20. Then from B0 to B4, sorry, this is a distance of 2. So round trip takes 4 seconds. So this becomes 4 into how many times do I visit it? 6 times. So I'll say 4 into 6, this is 24. And then this takes, to B5, this takes 3 seconds. Round trip is 6. 6 into 1, this is 6. Let's add these. 12, 16, 20, 24, and 6. I think this gives you, of course, this gives you 78. And this is the answer. So we have actually printed 78. That is the minimum time we said is arguably the right one. And we also printed an arrangement of those buildings, which actually gave me this time. Okay, so I hope the question is clear. Pause the video, might get a little confusing. Once more, read the question, understand what is asked, the arrangement along with the minimum time, and then probably you can check out the other cases also and verify their answers turns out to be 18 and 14 so that you get a grasp of this building placement that we are talking about. All right, great. So I think we understood the problem. Let's move on to discussing the time complexity. So it has been said that in one test, there is 1 second time limit, that is 10 power 8 order roughly. And then there is a test case variable. Although it has been said that sum of n over all test cases do not exceed 2 into 10 raised to 5 order. This means very simply that I don't need to bother with this t variable. I can directly have a check with n, that is the size or the number of buildings that I have. So I can write one test tells me 10 raised to 8 operations. N is given in 2 into 10 raised to 5 order. So either I create an O of n solution, a little larger, n log n, also going to work. A little larger, O of square root of n, also going to work. But if I go a little larger, something like n square, this is not going to work. Right up to constant time complexity, all of this is fine. So solutions like these are promoted, but solutions like this give me TLE. And this is my expected time complexity discussion. And this is helping me because now I have a brief idea. Don't create anything in n square or above. Create something that is n log n, or preferably lower. Okay. Let's begin with the idea and the problem. Now, the idea in this problem is very intuitive and very greedy. Think about this question with yourself. Imagine you are the businessman. Tell me if, let's say, there is a building. Let's say there is a building BI. And let's say there is a building BJ. If you visit BI, let's say VI number of times. And let's say you visit BJ, VJ number of times. Now, if VI is more than VJ, that means visits to the BIth or Ith building is more than the Jth building. Then don't you think that this building should be closer to your office or closer to your headquarters? It's very greedy. If VI is higher as compared to any other building, then this BI building should be closer to me as compared to the other buildings. And this is all the greedy idea that we need. So we can actually write this down in an argument that I want to place those buildings which I visit more closer, you can say closer to my office. This reduces overall time. By overall time, very intuitive. If the building that you visit more often is closer to you, the time contribution from visiting that building overall will also decrease. You can see this like this. For example, if you know that this is the location where your office is, and let's say this is where you place the building, so the time taken to go from here to here and then back, the sum of these two segments, whatever that is let's say D. And then this D is going to get multiplied with how many times do you visit it. Now, do you think you can change this V value? It's given. Whatever you do, V does not change. The number of visits to a building does not change. The only controllable parameter is D. So if you lower this D, overall this product also lowers, which overall lowers the summation, because this product for one building is again summed up with all such products. If everything goes down, overall sum goes down. Okay, this is a very simple idea. This means I now just have to figure out some arrangement which brings more often visited buildings closer to me. So I have a very straight idea for this now. Let's draw a number line. Let's say first I need to figure out where do I actually place my office. Now, initially the office wherever it is placed does not matter. So let's keep a very intuitive portion over here. Let's say that the number line has a middle part that is 0, right? And keep the office at this location. So this becomes B0, building 0, office, headquarters, whatever you call this. Now, let's say I know that the most often visited building is B1, then B2, then B3, then B4, and so on. Let's say I've somehow already done this for myself, that I know B1 is most visited, B2 is most visited, then B3 is most visited. If I know this, then all I need to figure out is where do I start off by placing B1? Remember, closer B1, lesser the answer. Let's see. Now you want integer coordinate placement. So from 0, you can mark these coordinate charts. This would have been 1, this would have been 2, 3, 4. Similarly over here, -1, -2, -3, -4, so on. Tell me, if B1 is more visited, should I place it at this location? Should I place it at this location? No. I'll take up a location. Let's say I place it at this location. Why is this good? This is the closest location right now that is available from B0. It only has a distance of 1 on a single trip, and coming back, double that, which is of course smaller only because initially this segment is also the smallest possible. So if I make sure that greedily B1 comes at this place, then overall I know right now B1 is greedily at a location where I know that answer for B1 is as low as possible. I think this makes sense. Next time when we go to B2, where do I place B2? Now remember, when you move from 0, when you go to left or to right, it doesn't matter are you going in the negative or positive direction. It just matters how many units do you travel. So if I place B1 over here, I can place B2 over here. Why? Because even from B0 to B2, the distance is 1, and coming back the distance is 1 again. So this overall distance is still 2. Similarly, B1 also had that distance 2. So right now you have occupied the next best location, which overall gives you a round trip of 2. Hence minimizing this D value that we just discussed for B2 also. Now let's go to B3. Now you've used up the best locations as of now. That was B1 and B2 placed. Now let's explore the next best locations. Very obvious, very intuitive. Let's start placing B3 over here. Now this is the next best location because this has a distance of 2. Round trip becomes 2 again, so this becomes 4. So next best distance is 4 over here. Similarly, let's place B4 now, and this is again going to give you a distance of 2, round trip 2, so overall a distance of 4. So I think you observe the pattern now. What you would want to do is place B0 at the 0th location. Then you just need an alternate placement. B1, B2, B3, B4, B5, B6, B7, so on like this. This is the alternate placement that we want. And if you're able to do that, it's guaranteed to achieve a overall sum to be the lowest possible. Okay, I hope this makes sense. Let's actually take up this second test case once more and see how did this work out for us. Okay, so as I said that you had 5 buildings, 3, 8, 10, and then 6 and 1. So now according to my algorithm, what will I do is, if this is the number line, I'll say that at the 0th location, I'll place B0. Then I can just mark these buildings first of all. This is 1, 2, 3, 4, 5. Now at the 1th location, which building do I want to place? The guy which has the more visits. Remember, we already did this when we saw this case over here. I said B1 is the guy which is the most visited. So let's figure out which do I pick up from here. Do I pick up this building? Of course, because this is the most visited. So this acts as my V1, you can say, and I'll place B1 all in this index format. Don't get confused. You can say this is where B3 gets placed. Okay, because this is the highest visited, 10 visits. Then over here, -1. I'll place this guy. This has the next greatest visits, 8 visits. So I'll place B2. Then back again. So alternate way is done. Now let's jump to 2 distance. Now you will have the next best guy is at 6 visits. So you'll place B4 building over here. Then come to -2. Next best visit is 3 visits. So place B1 over here. And then at the 3rd location, final building B5 over here. Let's quickly calculate for everybody and see whether our answer matches with the final case. For B1, let's say I'll go iteratively, B1, B2, B3, B4, B5. So for B1, I would want a distance of 2, then double it because a round trip is there. So 4 into how many visits? 3 visits over here. So 4 into 3, this is 12. For B2, similarly, 1 is the distance for 1 trip. Round trip is 2 seconds. 2 into how many visits? 8 visits. So this gives me 16. Then over here again, 2 into, you can say 10 visits. So this gives me 20. This is for B3. Then B4 has 4 into how many visits? 6 visits. So this is 24. And then 3, or sorry, not 3, round visit is 6. 6 into 1. This is 6 overall time. Okay. And now if I get the overall sum, 12, 16, 20, 24, and 6, this also gives me 78. So did our arrangement work out? Yes, it did. They gave you a different answer, of course, in the test case to confuse you, as we discussed it over here. This was not exactly the arrangement that we created, but you can imagine that yes, even our arrangement worked out and it gave the right answer. And if you pause the video and do this arrangement for all the other cases also, just by fixing at 0, then 1, -1, 2, -2, 3, -3, so on, you will actually see that you still are able to manage and get the best answer possible. Nothing better than that is there. Okay, so this problem has fully, I think, boiled down to a greedy plus pattern based question. All you had to first of all understand this greedy idea of which variable is controllable. Since D is controllable, let's minimize it, eventually minimizing the whole sum that we want to find. And if this is controllable, let's follow a pattern of placing 1, -1, 2, -2, so on, so on. Now, implementing this question is all that we would want to do, and that can have various sort of methods you would want to follow. I would present some piece of my code to you. You can definitely pause the video over here and try this once more on your own. And if that works out, great. But let's jump to the code part and see how do we implement this out. Okay, so what I'll do is very, very basic. I'll pick up the variable for test cases. Then I have the variable for n. Then I take the input of n, that is input of array, that is buildings visits, basically you can say. Now I have created a vector of pair of long, that is building map. What do I mean by building map? I'm going to push back in this building map the visits, comma, I. So which building's visits is there, comma, which building that is, ith building, as a pair in this. And when I do this, I'm going to reverse sort it. If I reverse sort it, automatically the buildings which have more visits come to the front, because now the first parameter right now is AI. So AI, larger AI comes on the first end. And if AIs are equal, then it doesn't matter which building is preferred. It's almost the same. So I think you're able to understand this works out. Just getting the larger visited building in the initial format. Now I have an answer vector that I actually want to print. That's the arrangement. Answer of 0 is 0. Answer of 0 basically means 0th building, headquarters. Where is it? At the 0th location. So I just initialize it back, although it doesn't make sense, but okay, just for the sake of the question, you can say. Then I have minutes. That is my main answer that I would want to print. The lowest minutes I have starts with 0. What is the coordinate I'm beginning of it? So 0 has already been occupied. So I want to begin with 1. Then I'll go to -1, 2, -2. I'm going to jump between this. So coordinate right now is 1. I go to every building in this particular building map that I created. Now I'll say answer of building map of I dot second, that is the index, Plus 1, why plus 1? Because I am basically maintaining a 1 based indexing in this answer since 0 already was occupied. So I need a plus 1 over here is equal to the coordinate. So 1 coordinate, you can imagine, gets occupied right now. Then how many minutes do I get added? 2 by 2 because there's a round trip. So 2 into absolute of coordinate. Why did I take absolute of coordinate? Because you can imagine that basically if you have to calculate what is the amount of travel you would require from, let's say, B4 to B0, that's basically this 2 value, right? You can either say 2 minus 0 or you directly calculate 2. And similarly, if you would have done for B1, that's basically negative 2, but negative 2 doesn't make sense in distance. So you can just take a positive of that or absolute of that, which is 2 distance again. So we just want the absolute distance. I'll say, okay, absolute of coordinate into how many visits were there? Building of I dot first. This is the minutes that get added. And then I change my coordinate to occupy the next building. So if my coordinate is lesser than 0, that means basically something like this happened. I occupied 1, then I occupied negative 1, and now I'm in the negative phase, so I want to jump to 2. So if this happens, I would want to make my coordinate become absolute again, positive again, plus 1. So if it's at negative 1, I want to make it to jump to 1 again, plus 1, that is 2. If it would have been at negative 2, I want to make it jump at 2 plus 1, so 3. So if it is as negative coordinate, it becomes absolute coordinate plus 1. Else, this coordinate right now was positive. I want to use its negative pair. So coordinate equals to negative of coordinate. Okay. Again, as I'm saying, this might be not a very clean implementation for you all. So you can pause the video and try to do this with your own logic. Maybe you can relate something with I over here on odds and evens, something like that, whatever you want. This is just a pattern building question. Okay. I hope this part is clear. Now, when I end this for loop, I know I have made the sequence also very correctly and I have the best minutes possible. So I'll print minutes first, that was required, and then simply print the array with spaces and change a line. And this is my overall solution. Now, if I look at the time complexity, I have an n order over here to take the input and then an n order over here just to create the building map. Pretty simple. This bunch is constant. Now, this is actually a little larger. This is reverse sorting, that is n log n. And then I have this n order over here to get my answers also. So I think the best term you can take out of this whole code piece is going to be O of n log n. Now, n being 2 into 10 raised to 5 order, if I plug this as O of 2 into 10 raised to 5 into log base of something, this is roughly like 10 power 6 order. And what is space? Space is only O of n, which is 10 power 6. Okay, so this is the whole problem. This is the whole question. Greedy plus pattern based approach is what was required. Pause the video, understand this question, and you can revise this once more if you want. And I hope that clears up. That is all that is there in this video. I hope you like it. Thank you for watching.